Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right. All right, let's see. Check this, right. Okay, so before we get started or get rolling in anything, anybody have any general questions? Everybody doing okay? All right, everybody's good. Oh, somebody in the chat. Okay. Okay, not a problem, not a problem. Thanks for letting me know. All right. So you guys can correct me if I'm wrong. If I'm not mistaken, we started chapter 10. Did 10-1, 10-2, and 10-3. We did graphing. Left off with vertical lines, horizontal lines. Intercepts was 10-3. So today we're starting off with 10-4, which is slopes. Like I said, feel free to let me know if I got a lot of classes going on, so feel free to let me know if I'm in the wrong spot for you guys, but I think I'm good. Checking one more thing before we get going. And 10-4, 6. Okay. All right, so 10-4 slopes. And we will use M to represent slopes for us. Can't use S. S represents too many other things, and whether it be the world of mathematics or the world of physics. So we're going to use M for slope. So the way we'll calculate our slope, that'll be y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. So I noticed that it doesn't matter which one you use, you still get the same result. And I will show you that in a second when we do our calculation. You only have to do it one way, but it doesn't matter which way you do it as long as you stay consistent. Notice that in this first relationship, y2 and x2 are first. In the second one, y1 and x1 are first. So it doesn't matter which way you do it, as long as if y2 is first on top, that means x2 is first down bottom. Or if y1 is first up top, that means x1 is first down bottom. And then the last part of the relationship is rise over run, which we will use to graph. We use that relationship to graph. And x1, y1, and x2, y2 will be 2 points, any 2 points on the line. All right.
Hey, Mr. Tucker.
Yes.
All right, hold on. I'm on the first part, right? The first part down. Is that a y1?
Right here?
Equals y1 minus y2.
Well, y1 minus y2 is the second one. So we have M is equal to y2 minus y1 over x2 minus x1. And then up here is y1 minus y2 over x1 minus x2.
Thank you.
Not a problem. All right, scrolling up. We're good. Okay, so for the first exercise, it asks us to find the slope. They give us 2 points that are on the line, -2, -4, 3, -5. And I didn't mention this, but your slope is exactly what it sounds like. Like you talk about the slope of a mountain or the slope of a ramp or the slope of a roof. You're talking about the incline, the slant, how steep something is. This is just numerical value and direction on, like I said, that steepness or that slope. So that's what you're doing, put numerical value and direction to that. So if you have 2 points, it is in your best interest to call which one point one and which one you're going to call point two. Go ahead and establish which one you're going to call point one and which one you're going to call point two. It does not matter. Normally, I just call the first one I see point one, which is -2, -4, and then the second one, point two, which is 3, -5. All right, so like I mentioned, as far as the formula is concerned, I'm going to do it both ways first, just to show you that either way you'll get the same answer. But when you're doing it on your own, you only have to do it one way. So the first one, y2 minus y1 over x2 minus x1. Y2 is -5, y1 is -4. Make sure you don't lose a negative. A lot of times, if anyone's going to make a mistake on these, they lose a negative when they do their substitution. There's a minus sign in your formula, and you're plugging in -4. So make sure you're careful with that. Then you do x2 minus x1 on bottom. So x2 is 3, x1 is -2. Once again, don't lose that negative. So in both cases, top and bottom, negative to a negative turns positive. That's why I circled that, and that'll give you -5 plus 4 on top, 3 plus 2 on bottom, and that'll be -1/5. That would be your slope. You don't have to convert that to a decimal. All right. So next one is just reversing the order, y1 minus y2 over x1 minus x2. Once again, just to show you that either way you'll get the same result. So that's -4 minus -5 over -2 minus 3. So that's -4 plus 5, which is +1. And we have on bottom -5. That's still -1/5. So either way, you'll get the same result as long as you stay consistent in your substitution. If y2 is first on top, x2 is first down bottom. If y1 is first on top, that means x1 is first down bottom. All right, scroll up.
You explain that part one more time.
You just substitute in according to the points that you have. Y2 is x2 and y2 is 0.2. X1, y1 is 0.1. And you'll substitute in according to the formula. Got y2 is -5, y1 is -4. And then x2 is 3, x1 is -2. So we plug them in and you get -1/5 once you do your calculation.
I got a little confused about the formula part, but I wrote it down on the top, so I got it.
Okay. And so just to, okay, so that's fine. And then go down here is the same exact thing. It's just that we just reversed the order. And all I was showing you there is that either way, you'll get the same answer, -1/5. So you don't have to do both ways. I was just showing you that either way, you'll get the same result. Yeah.
Okay, appreciate that.
Yep. So we about to do another one just to reinforce. So is everybody good with this one before we go to the next one? All right. So same directions. 5, -6, 8, 3. 5, -6, I'm calling point 1. 8, 3, calling point 2. All right. So make sure you substitute correctly. We call them y2, 3, and y1, -6. So if I'm doing it in this order, y2 minus y1 is going to be 3 minus -6. Then down bottom, x2 is 8 minus x1, which is 5. So it's 8 minus 5 on bottom. So that'd be 3 plus 6, which is 9. 8 minus 5 is 3. And then 9 divided by 3 is 3. All right. Any problems? Any problems? Make sure you're okay with the substitution. All right. Can you scroll up? All right. So basic behaviors of your slopes. So we have 4 basic behaviors. If following your graph or following the line, your line goes up from left to right. We always follow from left to right. If it goes up, your slope is positive. If going from left to right, it goes down, your slope is negative. If it's a horizontal line, your slope is 0. And if it's a vertical line, your slope is undefined. So those are your 4 basic types of slopes: positive, negative, 0, undefined. Any questions? Any questions? All right, scroll up. All right. So parallel lines. So there are lines that never touch or cross. They have the same incline, in other words, the same slope. All right, they have the same slope. Perpendicular lines, they're lines that create a 90-degree angle at intersection. And their slopes are negative reciprocals of each other. So we'll talk about what that means in a second. Give you a chance to write. All right. So what does it mean to be negative reciprocals? First of all, reciprocals are just flipping a fraction. So that's what we're looking at right here. On this left side, if you're talking about your reciprocal of your fraction, you're just flipping a fraction. So 4/5 and 5/4 are reciprocals of each other. Sign stays the same though. -10/7 and -7/10 are reciprocals of each other. Once again, sign is the same. And then 8 and 1/8 are reciprocals of each other. But what we want are negative reciprocals. So negative reciprocals mathematically means negative means opposite. So that means we're going to flip the fraction and use the opposite sign. So that's why I wrote right here in the green. Going to flip the fraction and use the opposite sign. So if we have perpendicular lines, their slopes are going to be negative reciprocals of each other. So 4/5, you would flip it 5/4 and use the negative sign. If it was negative 10/7, you flip it and turn it positive 7/10. And then with positive 8, that'd be negative 1/8. Oh, did I just do something? Okay, cool. All right. Questions.
Mr. Tucker,
Yes, sir.
like I'm looking at the reciprocals right here.
Mhm.
You see negative 10/7.
Mhm.
Does the whole fraction is negative or just that 7?
The whole fraction is considered negative.
Okay.
Yep. And so whether you write negative 10/7, or if you write 10/-7, or you put the negative out front, all of that still means the same thing. Yeah, all that's the same thing. Good question. All right, can we scroll up, put this to work a little bit? All right, so next directions, it says give the slope of the line that's parallel and then give the slope of the line that's perpendicular. So they're gonna give us an original slope and okay, then we ask you what's the slope of the line that's parallel to this one, then what's the slope of the line that's perpendicular to this one. I'm gonna erase this stuff and just walk through it. Yeah, well. All right. So they give us the line that has a slope of 3/5. And if I want the line that's parallel to it, it's going to be the exact same thing, which is 3/5. Parallel always has the same slope. All right. If you want a line that's perpendicular to it, you flip it and use the opposite sign. So it's going to be 5/3, and it's going to be negative because the original slope was positive. All right. Questions on that, on those relationships before we look at the next one. So once again, parallel lines, same slope. Perpendicular lines, you're going to flip the fraction and then use the opposite sign. So that's how we do that. All right, next one, negative 11/9. Once again, parallel lines, same slope. So that still would be negative 11/9. And then perpendicular, we flip it 9/11, and it's going to be positive because the original was negative. Use the opposite sign. And then one more example. If our slope is 1/7, parallel line would be 1/7. And then perpendicular line, negative 7/1. So it's just negative 7. All right. So let's graph using the slopes. So remember I told you that last part of the relationship, that rise over run, is what we use to graph when it comes to our slopes. The rise represents up or down. The run represents right or left. So what dictates whether we go up or down, right or left, will be the positive or negative sign. So positive moves are up and right, negative moves down or left.
Mr. Tucker, you scroll up to that last 7. This M1, right? It's that perpendicular. So why isn't that flipped?
Right here?
No, the next one.
We did flip it because it was 1/7. Now it's 7/1.
Yeah, okay. Yeah. Okay.
All right. All right. Scroll up. Are we good? Scroll up a little bit. All right. So if we have a +3 over a +4, both of those are positive moves. So that means we'll go up 3, right 4. Now we have -5/7. That's down 5 because the 5 is negative, but the 7 is positive. So whenever you have a negative sign, you have to assign the negative to, as far as when it comes to the slope, you either have to give the negative to the top number or the negative to the bottom number. Can't do both because negative over negative, remember, that would be positive. So that's why you can't give 2 negatives. So when you say, if you're talking about sign of direction, I normally say just go ahead and give it to the top and just leave it at that. So making that negative top number over a positive bottom number. If that's the case, then that's down 5, right 7. But if you decided to assign it to the bottom, that means you have a +5 over a -7, and that'll be up 5 and left 7. But regardless, either way, it'll still give you the same line. So if I was letting this be my original point, if I go down 5, left 7, that'll put me over here. Or going back to my original point, if I go up 5, left 7, that'll put me here. So either way, it will create the same line. So it doesn't matter which one you do as long as you do it correctly and you only give the negative to one or the other as far as direction is concerned. And you'll be fine. All right, can I scroll up? All right, so we're going to use a slope-intercept form in order to be able to graph with the slope. We notice our equations in the form of y = mx + b. You solve one side for y, get y on one side by itself. And what's sitting in front of x is your slope, and then the other number is your y-intercept. So if you have one side, solve for y, and the other side simplified as much as possible, then whatever's sitting in front of x is your slope, and the other number is your y-intercept. All right.
Hold on, Mr. Tucker. What is that word right there under Y?
Under, you talking about right here?
Yeah, what's that?
Where? W-H-E-R-E. I can write that better. All right, let's scroll up. Good. So in the red, just a few examples of how we can pick out information from an equation if it's in slope-intercept form. So if our equation is solved for y, once again, and everything on the right is simplified as much as possible, what's sitting in front of x is our slope. So that's why we have your slope is 2/3, and the other number is your y-intercept. So y-intercept is 1. If our equation is y equal to -8/13 x minus 5, -8/13 is our slope. Y-intercept is -5. All right, ready to use this information? All right, so as far as directions on graphing, what we're gonna do is plot that y-intercept first. You notice I try to underline and circle first because that's major. We're gonna plot the y-intercept first. Then we're gonna generate another point from the y-intercept. We're not gonna go to the origin. We're gonna generate another point from the y-intercept with the slope. Because remember, our slope is not a point. It is a set of directions. Go up to the right, up 5, left 7. You know, they're directions. So we don't go to the origin, we go to the y-intercept from the slope, with the slope. All right, we'll erase this. All right, so let's take the equation of y equal to 2/3 x minus 1 and extract all the information from it first. So what's sitting in front of x is your slope. That's 2/3. Both of them are positive, +2 over +3. So it means we're going to go up to right 3. Your y-intercept is -1. And because it's your y-intercept, they assume you always know that the 0, the x is for the x component of your y-intercept is always going to be 0. There's always going to be a 0 where x is. So that's why we have 0, -1. So remember, we talked about y-intercepts last class. Characteristic of all y-intercepts is that x is 0. Just like characteristic of all x-intercepts is that y is 0. All right. Everybody okay with this part first before we look at the graph? All right, so like the directions say, plot the y-intercept first. That's why I have this point right here, 0, -1. Don't move left or right for x, but go down 1. And so you plot your y-intercept first. Then from there, from your y-intercept, you go up to right 3, and that'll put me right here. And that's your line. And if you want, you can continue to generate points on this line, going up 2, right 3, up 2, right 3. You know, it'll put you here, up 2, right 3, put you here. It'll keep generating points on the line, just going up 2, right 3, up 2, right 3, up 2, right 3. So, but that's how you would do it. Questions before we do another one? Make sure we're okay. All right, let's try it again. So here we have y equal to negative 1/4 x plus 3. So negative 1/4 is our slope. So it's negative 1 over a positive 4. So I'll go down 1, right 4. Y-intercept is 3, 0, 3. All right, so graph 0, 3. So you go up 3 on the y-axis. So you graph that first. And then from 0, 3, you go down 1, right 4, which will put you right here.
Mr. Tucker.
Yep.
We keep, is it any instance going to be two, like double negative? Like
No.
-1, -4, you know what I'm saying?
No, it wouldn't, because negative over negative is simple, more simpler wrote as positive 1/4. So you would get positive 1/4. Mm-hmm. So yep. So you wouldn't get that. All right. So then go ahead and draw the line, and that's your line. All right. Questions? Got at least one more. All right, so 5x plus 2y equal to 8. So the previous two had our equation solved for y already. If your equation is not solved for y, then you do need to do that if you're going to use this method of graphing. So we have 5x plus 2y equal to 8. Y is right here. We need to get this y by itself. So the first thing we would do is subtract 5x from both sides. And that puts us at 2y equal to negative 5x plus 8. Then divide by 2. And that 2 has to go into both pieces in our numerator, which will give you negative 5 over 2 plus 8 over 2. And when you simplify that, that'll be negative 5 over 2x plus 4. And so that's a position we want to be in, which is this one, y equal to mx plus b. So we can pick out what our slope is and what our y-intercept is. All right, we good. So the slope is -5/2. Y-intercept is 4. So if it's -5 over +2, that means we go down 5, right 2. Y-intercept 0, 4. Because remember, if it's your y-intercept, then x is always going to be 0. Grab that 0, 4 first. That's what we did here. And then go down 5, right 2. That gives us this point right here. All right. Questions, questions, questions. Are we good? Are we straight? Questions before we go to the next page? All right, let's do at least one more thing today. This is 10.5. That was 10.4. Let me see, 5, 6. Hold on 1 second. Yep. 1, 2. Okay. All right, so let's do 10.5, equations of lines. And we'll call it a day. So it starts off with the point slope formula or point slope form. Where y minus y1 is equal to m times x minus x1. Where m is our slope, x1, y1 is any point on the line. So we're going to use a slope and a point to create an equation for what we want or what we're looking for. So y minus y1 equal to m times x minus x1. All right, so before that first test, it was 9, 5, and 9, 6. So somebody said in the chat was asking about the first test. The last two sections before the first test is 9, 5, and 9, 6. All right, scroll up. This really wasn't needed. All right, so we're gonna use that in this next equation or next exercise. It says write an equation of the line with slope 2 and pass through the point -4, 6. So we have a slope and we have a point that's on the line. If you have a slope and a point that's on the line, you can write an equation for it. So here we're just labeling the given information. M is our slope. So M is equal to 2. X1, Y1 is our point, -4 and 6. So looking at our formula right here, Y minus Y1 equal to M times X minus X1. Notice we're plugging in for the values of X1 and Y1 and M. So X, the regular X and the regular Y still going to be a part of your equation. So this line right here is that substitution. Y minus 6 equal to 2 times X minus -1. Make sure, -4, excuse me. Make sure you don't lose a negative. All right, you can distribute that 2. And negative to a negative turns positive. So we're looking at Y minus 6 equal to 2X plus 8. Then to make it as simple as possible, simplest way of expressing this equation as possible, we'll add 6 to both sides. And now we have the equation of Y equal to 2X plus 14. Now they didn't ask you to graph it, so you can leave it right there. If they were to, then you know, oh, still my original. Then this would have been the information you could have pulled from it. So that's all I was emphasizing there. 2 is your slope. Y-intercept is 14. Any questions? Oh, somebody in the chat. Oh, financial aid. Yes, if you buy it through TCC. Yeah, if you buy it through TCC, Barnes and Noble's bookstore, you can use financial aid. Yeah.
That I ain't received access to the thing. I bought my little book, but I ain't received access to it. Do you send an email or something?
Now, did you buy? Who'd you buy the book through?
Barnes and Noble.
Yeah, it should have. It should have came along with it. You need to check with them on that. They should have given you an access code.
Yeah, I was wondering would it be an email or something? Okay.
Yeah, you're gonna have to call them and check on that. Make sure. Yeah. All right, let's do another one. Write an equation of the line with a slope -2/3 and runs through the point 5, 0. So it's the same exercise, just change the numbers, change the process. So M is -2/3. Y1 is 0, X1 is 5. So we plugged in those pieces right here. All right, then we would distribute. So this 0, just Y minus 0 is just Y. So that's why it's just a Y over here. And then we distribute the -2/3. -2/3 times X is -2/3 X. But then -2/3 times -5. I did the work over here. All we did was multiply across. -2 times -5 is +10. Down bottom, 3 times 1 is 3. So that's just 10/3 as our answer. Questions on that? Make sure we're okay. All right, scroll up. You okay? A couple more just to make sure we're all right. For the next one, write the equation of the line that passes through. We have the points 3, 4, and 5, -4. So notice this time they didn't give us a slope, but they gave us 2 points. So we need a slope. We need a slope in order to create the equation of the line. So we'll find that first by using a slope formula. Y2 minus y1 over x2 minus x1. Once again, I always establish which one I'm calling point 1, which one I'm calling point 2 first. And then I go about my substitution. So then that'd be -4 minus 4 on top, 5 minus 3 on bottom. Gives me -8/2, which is -4. Any questions so far? Make sure we're okay. All right, can I scroll up? So now we're going to use our point slope formula that we used in the previous example. It doesn't matter which point you use. You can use either one of these points. Doesn't matter which one. I normally just use the one I already called x1, y1. But both points run through your line. So either one will give you the same result. So y1 minus y minus y1 equal to m times x minus x1. We have our slope, which is -4. And like I said, I use 3, 4 for x1, y1. Substituted in accordingly right here. So it's y minus 4 equal to -4 times x minus 3. Distribute that -4, that'll be -4x plus 12. And let's see, did I go to the next part? No. So this one asks for standard form. And so standard form is ax plus by equal to c. So you take your x term and y term, put them on one side, take the term that doesn't have a variable and leave it on the other side. So notice what I did right here. I added 4x to both sides and then added 4 to both sides. So that put the 4 on the right, brought my 4x over to the left. And so my result is 4x plus y equal to 16. So I just took this and converted it to that form. Make sure you're okay before we leave the problem. All right. Can we scroll up? Anybody still copying? Okay, next one. Write the equation of the line. That passes through the point 1, -1 and is parallel to 2x plus 3. All right. I want to write the equation of the line that passes through 1, -1 and is parallel to y equal to 2x plus 3. Okay, so don't forget, if it's parallel, should have the same slope. So the slope of this line is 2. So it means the slope of the line is parallel to it should also be 2. So it means we have a slope and we have a point in 1, -1. All right, everybody okay with that? Once you have slope and that point, then we use our point slope formula. Y minus y1 equal to m times x minus x1. Plug in -1 for y1, 2 for m, and then 1 for +1. I mean 1 for x1, excuse me. Negative and negative turns positive. That'll be y plus 1 equal to 2x minus 2 once you do your distribution. Then subtract 1 from both sides. Y is equal to 2x minus 3. All right, any questions on that? All right, got one more. Is everybody okay with this one before we move on? All right, next one, write an equation of a line that passes through -4, 2 and is perpendicular to 2y equal to x plus 7. All right. So don't forget, if it's perpendicular, that means the slopes will be negative reciprocals. So I need to solve this equation for y in order to figure out what the slope is and then get the negative reciprocal from it. So that's what I did here. Y was not by itself, so I need to divide both sides by y. That's what I did right here. And that gave me y equal to 1/2 x plus 7/2 right here. If you're just picking out the slope is 1/2. But remember, I need a slope that's perpendicular, or a line that's perpendicular to it. So the slope is going to be the negative reciprocal. You're going to flip it and use the opposite sign. So that's why you flip 1/2, which is 2/1, and then make it negative. So it's -2 as our slope that we're going to use. Once again, we want a line that's perpendicular. Want a line that's perpendicular to this line right here. And we use the negative reciprocal. So before we go to the last part of this problem, is everybody okay with what was done? Scroll up. So now that we have a slope, which is -2, and we have a point which was given -4, 2, we can use our point slope formula. Y minus y1 equal to m times x minus x1, and plug in accordingly. Y1 is 2, m is -2, and then x1 is -4. All right, -2 and negative turns positive, so it's going to be x plus 4 in the parentheses. All right, so I could have wrote that here just so we make sure we're good. So it's x plus 4. Then when you distribute that -2, it turns it into -8. So that's why it's back at a negative. So you have -2 negative, which turns that positive to a +4. Then distribute -2. That'll be -2x minus 8. That's why that happens right there. And then add 2 to both sides. That'll be y equal to, excuse me, y equal to -2x minus 6. If they ask for standard form, remember your x and your y term will be on one side. So just add the 2x to both sides to take it back over. And that's 2x plus y equal to -6. So, this one is slope intercept form. This one right here is your standard form. So they could ask you for either. All right. Questions on anything that I've written? All right. Everybody good? Everybody straight? So next class, we're only going to do one section, which is 10-6. And so that means there will be opportunity for you to ask questions next class as well. So feel free to bring them so we can talk about them and make sure you guys are good moving forward. But that is it as far as lecture is concerned for today. Did anybody have any questions on anything before we close? Make sure we're good. Some stuff up here, stuff that we talked about today may not, questions may not be generated until you actually get into the work. So I understand that. But if you got other stuff, the floor is yours. Everybody good? All right. So like I said, next class we'll do 10-6. Don't forget to get with Mr. Davis on testing, and also we'll probably next class talk about an opportunity for you to take a test in class as well. In this class, during this class setting. So don't let me forget to talk to you about that. Other than that, you guys have a good one. Be safe, and I will see you next class.
Have a good one.
Thanks. You do the same.
Are the classes online or do we go on campus?
When you say classes online, you mean tests? Or
I mean, yeah, the tests.
the test will be online as well. Mm-hmm.
All right.
All right. Take care.